Hello all, thank you for coming to our webinar today. My name is Brian Tuemmler. We're going to be running through a bunch of very interesting stuff about voice transcription and big audio and how it relates to the Enron dataset. I wanted to just briefly say that this started mostly as a benchmarking project to measure performance and speed, but it really brought up some interesting bits and pieces about the Enron dataset, and we thought, well, this is a really interesting story, so maybe we should just tell it as a webinar. So that's kind of why we're here today. I'm going to start by introductions. Michael Lappin is going to be speaking and presenting with me. Michael, are you there?
Hey everybody, good morning, good afternoon. Glad to be here. Thanks, Bri. So I actually have the privilege of running the solutions consulting team for the Americas. So that's some of the finest solutions consultants in the world. And I also had the privilege of working on the Enron dataset cleansing with the EDRM group on what's called the dataset working group. So I'm eager to hear Brian expose some of that for us today.
Great. Thank you, Michael. And my name is Brian. I've been working basically for a long time in the information governance space, cleaning up shared drives, classifying records, doing a bunch of things related to information governance. Very much on the proactive rather than reactive side of managing information. I'm currently the information governance product manager at Nuix, and I've got a couple of products under my control, Nuix Voice being one of them. As I mentioned, this was a project that we put together just to build some benchmarks. If you know Nuix, you'll know that it's important to us that we try not to overstate or understate our capabilities. We want to be as honest and clear about what we can do and can't do so that when you get to be using Nuix tools, you're not surprised. And that was part of the goal of this particular process, is to make sure that we had some good benchmarks about what the Nuix Vokey relationship is, and we'll talk about that. Real briefly about Nuix, just in case you haven't run into Nuix, I know that there's a number of people on the webinar that are Nuix partners or Nuix clients. So I'm not going to spend a whole lot of time on this, but in general, at a high level, what Nuix is an engine that goes through unstructured content from a number of different sources, including things in the cloud, on-premise, email systems, and we build a very large index, comprehensive index of all the content that we come across so that you can then enable a number of different activities. Mostly in the US, it's around eDiscovery and forensic investigations. We've also got a number of capabilities for information governance type activities such as mergers and acquisitions and compliance, risk management, records management, a lot of the different types of activities that are out there from an IG space. When we find a file, like a TIFF file, we send it off to OCR. When we find a photograph, we extract out the XY coordinates. When we find a Word document, we extract out all the text. And until recently, we didn't have anything good to do about audio files. Yet audio files make up a large percentage of a number of litigation cases and compliance cases. So we needed to find a solution to it. We wanted to be able to incorporate all of the text that you can search in audio files and bring them into a discovery case or an investigations case or an IG case and figure out what does that mean for you and how can you move forward with that. That's who we are as a company, and that's kind of why we took this approach. What we're going to talk to you today, give you a brief introduction to Enron and why it's near and dear to Nuix's heart, and probably a number of other eDiscovery and investigation tools that are out there. Briefly about the Enron corpus of emails, where it came from, what it means. We'll talk about the Vokey benchmark, and along the way, what were the lessons learned that we got out of analyzing that data. And then we'll give you a quick demo so you can see what the tool looks like and how to move forward. I've tried very carefully not to make this a sales presentation so much as an educational presentation. I've only got 1 or 2 sales-related slides, so I apologize for those. But when you get to that, I want you to be well-informed as a result of this. The one other caveat is that all the information about Enron, the Enron dataset, Snohomish Power, and all the other external references in this particular presentation come from public data sources. I have a complete lack of journalistic integrity, so I didn't call anybody or validate any of my sources. Just want you to know that comes from, you can look all this stuff up. If you wanted more details about anything related to this, about Enron or Snohomish, feel free to go look that up. It's out there. So first of all, who's Enron? Enron, an energy and power company. They earn profits by providing wholesale trading and risk management in addition to a bunch of electrical, natural gas storage and processing facilities. So they were a buyer, basically a buyer and seller of energy, a number of different sources, a number of different ways to do it. there are ways that they were supposed to be managing their profit models, and whether you are reselling or selling directly or doing whatever it is with your profits, they were using an incorrect model to determine what their profits were. In October of 2001, which happens to be, and I can tell you this by looking at the Enron data set, when Britney Spears was quite popular, a reporter reviewed the company's 10K report where she found strange transactions, erratic cash flows, and huge debts. And that started off a fairly large case that went in a lot of different directions. As part of that litigation case, a lot of emails were captured. So there, Ken Lay, Ron Skilling, a number of other people related to the case, all of their emails were provided as part of the eDiscovery, and at the end of the case, the judge made that publicly available. So suddenly, all of us who were in the world of analyzing and understanding email systems and evidence for court cases now had something that we could latch onto that represented a real-life, real actual case of data with a lot of good information in it. Following from that, there was also a collection of 2,800 hours of audio recordings, conversations that Snohomish Power got a little frustrated with the FERC for not necessarily analyzing in a quick fashion, so they decided to go off on their own, transcribe all that audio and figure out what it said. And we'll talk about the differences between what was in the email systems and what was in the voicemails as we go on through that. But generally, the Enron data set, when it came out, the version 1 of the Enron email set was hosted by the EDRM. It served for a number of years as a collection of email data that represented a real-life business collection of content. It was a fairly open secret that it contained a lot of instances of private health financial data. It also contains references to some of my former employers, a neighbor of mine who lives down the street who writes about energy stuff, a number of soccer team practice schedules, and all kinds of other stuff. So it's a very rich collection of all kinds of data that's out there. Since Nuix is in the business of looking at and cleaning up data, we went through a process as part of the EDRM initiative to clean that up. And so the Enron version 2 is now available for download at the edrm.net. Also worth mentioning that on the phone with us as part of this particular initiative is Michael Lappin. And Michael, did you want to say anything else about that?
Yeah, it was something that I used to work with the data set group at EDRM, and we actually took this on as kind of a fun but also useful project to see how much stuff we could really find, and then to repost that data set for additional cleanup if necessary, but just sort of a community project to work together as one to sort of clean it up and showcase what we could do around finding PII, among other things, in the set.
Cool. So this was our best effort. Diligence and reasonableness is often the guidelines and direction that you use for an eDiscovery or case, whatever happens to be. We processed the version 1 data set using Nuix 4.2.1. There were 1.3 million items in there. Now, I mentioned earlier there was fewer total emails in that. With the data set, there's often emails with embedded objects in them, and each embedded object may also have an embedded object in it. So the total corpus of the data set that we went through was 1.3 million emails and attachments. Discovered what we call named entities, which are really slightly sophisticated regular expressions. It's the ability to find patterns of information that's in the content. We sampled, scrutinized those entities, removed a bunch of false positives, things that we knew just weren't what the regular expression said that they were. We added a bunch of content to a relevant training set, and through our predictive coding capabilities within Nuix of that data set, we created a relevant training set and located basically several thousand business-oriented items and added these to the irrelevant set to come up with what content should be removed from that data set to make it PCI, PHI, PII compliant, so removing a bunch of content from it. And here's basically the fun facts of what we found in that data set. Removing 10,000 items. We found 42 credit card numbers within that data set. We found references to a date of birth 292 times in that content. Social security numbers, there were 541. Personal contact info, 6,000 objects. References to HIPAA, divorce, religion, 530. and a number of resumes, which contain a lot of PII as well. There were 3,000 of those. That was the first pass of what we removed from the data set to make it a clean set, and then basically reposted that back up as the clean data set that you can now find at the edrm.net. So moving on to the audio portion, this was a separate investigation done separately. For our benchmarks, what we had was 300 audio objects. There were actually 200 within there. There were unique objects of simultaneous transcripts. Basically, after removing immaterial items, non-audio files, and duplicates, it's about 200 objects that came out to about a day's worth of hours of audio. Consisted of WAV files and MP3 files. We loaded those all onto the file server local to the processing so that we could eliminate whatever performance might have been inhibited by our network connectivity. And then we basically loaded that on, indexed that along with the Enron email and document data set using our integration script. So that's sort of the background behind the benchmarks that we did. I'll give you some numbers from that, but first we want to talk a little bit about Vokey, because this is the tool that we use to provide this. From a Nuix perspective, if you're familiar with Nuix, it's a lot like being able to OCR your audio. The same way that we take a TIFF image and run it through an OCR engine, we're taking your audio and sending it through the Vokey server to get speech to text. It's a company out of Pittsburgh. We formed a partnership coming up on about a year ago, and we built an integration to their tools. As you can see, they are growing quite rapidly, doing a lot of good things. We'll talk a little bit about them later. This is the one sales slide. Basically, the sales pitch is that you can increase your audio speech to text processing by 100 times real time with 80% accuracy, chain that obviously varies, using an on-premise or cloud implementation of Nuix Voice. Combined with the Nuix engine, which is really the value add that we bring to the table, is the combination of being able to search voicemails and emails at the same time, and that's a large part of the lessons learned during this process that we'll talk about. But it's a low-cost, fast and accurate way to get all that audio out. There's obviously a number of use cases for transcribing audio, and this is a litigation response case, but there is also a number of compliance, regulatory audit use cases, and we'll talk about what some of those are as well. So the test that we did was basically running this audio set that we talked about through a Vokey Appliance in both Sydney and Philadelphia. We ran it through a VM on VirtualBox in an office in San Francisco, hosted on an R720 system. We ran it on a Vokey vTorch laptop, which is another way to deploy these. And then also ran some tests on the Vokey demo Amazon cloud server. So for the most part, we don't find a lot of clients who are particularly interested in using a cloud implementation, only because they're quite concerned with audio files leaving their premises. So we don't find as much pickup of the cloud-based installation, but if you need a cloud system, it does take advantage of the GPU processing speeds, and so you can get really good high-speed processing, and the files are encrypted from the source while they're in transition to the server and then back again. So there's a lot of good ways to apply this. We want to make sure that you have a good feeling for what all these things are. This is really the script that we have integrated to it. So normally what you would do is just load the files into the Vokey server. With our system and the integration, the first thing you do is filter out non-multimedia items from your selection. Because Nuix has gone through and indexed all the files, we can tell you which ones are MP3s, which ones are WAVs, which ones are this and that and everything based on their MIME type. And so it's an easy process to filter out, extract out things that might be emails that don't have any audio. The tool then checks the Vokey server to see if there's any existing transcriptions. The value in this is that if there's a file that you're sending that has already been transcribed, there's no reason to transcribe it again because you've already got one. So it checks to see if that transcription already exists, and if it does, it downloads it again. So it checks for availability. It downloads whatever existing transcripts are there. It attaches those transcripts to the audio files. For anything else for which there's not a pre-existing transcription, we batch them, upload them, process them, and then bring them back down, and once again load them into the system. And you'll see all this during the demo that Michael Lappin does. These are the speeds we found. The first one is the Appliance. Basically, the way we measure this is the multiplier of how many hours you could process in 1 hour if, in fact, you did that. So you can see that we were able to process the equivalent of 110 hours. We only had 28 hours to process worth of data, but the equivalent If we had had 110 hours in 1 hour, that's what our benchmark is for the appliance. We generally will say things around 100 times. There are some conditions, and we'll talk about what those are that impact the speed and performance. The VM is generally not the best way to go about doing that because you get just about 2.45 times actual processing speed. So those of you who have done manual transcription, you'll know that it doesn't take an hour to do an hour's worth of audio transcription because generally you'll listen to it 3 times to get all the text out, to get it as accurate as you'd like to get it. So this is really much better than real life, but still not necessarily taking advantage of all the capabilities that are in the Vokey server to get that speed. When we ran it on the laptop, obviously with a laptop you've got fewer processors and things run slower, but we still had 28 hours worth of audio processed in 1 hour. One of the other analysis that we did on this audio data was the difference between mono audio and stereo audio. Obviously, as you'll see, if you have stereo, you've got twice as many channels as if you've got mono. It's not necessarily a twice as fast proposition, but with the mono data, we were able to process 110 hours worth of data in 1 hour. With the stereo, it was about 30 hours in 1 hour. So it takes a little bit longer. There's a little more time to sort of map up the 2 conversations that go through in your audio. We're happy to talk more about that later. But in essence, there is a difference between mono and stereo and how you want to process things. That's part of the reason why doing a pre-upload division between your data is probably a valuable process to go through. If you know that all of your data is coming from the exact same data center always, then you've got fairly good control over what your audio looks like and sounds like, and you can tweak the recording process to make sure you're getting maximum throughput and quality. If it's a legal eDiscovery type case, you may not know where the data is coming from or what kind of quality it has before you get in there. And so it's a slightly different scenario. You might get better or worse results as a result of that. This was the Amazon cloud. This was a slightly different data set. It was about the same in size. Up in the Amazon cloud, we received a 23 times real-time processing, so 23 hours in 1 hour. As you can see, the Amazon cloud is able to take care of the graphical processing units, which is where we really achieve those speeds from. So this is an opportunity. If you're comfortable with the idea of having audio going up into the cloud, it means you don't have to purchase and acquire and install an appliance or a laptop or a VM. So some of the things that impact speed. The first is, as I mentioned, stereo and mono. Stereo files take twice as long to drive the text since there are twice as many channels. Also be aware that there are ways to record in stereo where both channels are recording the same audio. So if it's something like a video camera looking at a room of people, both the left and the right channel will be picking up everybody's voices. You'll just get a little more left on the left-hand side and a little more right on the right-hand side. That's different than a phone call where almost all the audio can be heard in one channel or the other channel, but not both. So processing mono through stereo process will still take twice as long, so there's value in separating these out. Your network speed does also play an impact and a role, so you don't want to place necessarily if you've got a very poor connection to where the server is, you will find the performance not running quite as fast as you'd like. And then finally, language pack complexity. So one of the things that Vokey is doing is it's building a transcript from the files. It's not just searching audio utterances, it's actually building words and comparing those words to what it finds in a dictionary. So if you have fewer words to pick and choose from, it'll go faster. So a very limited, focused, targeted language model will actually get you faster response time and in some cases actually increases accuracy because there's fewer words that the dictionary has to pick from in order to decide which word it seems to have heard. So with depending upon the language pack complexity, there's a number of different options with Vokey. The 2 standard ones are voicemail and call center, where a lot of the language that it's been taught have to do with the kinds of things that you would hear either in a voicemail or in a call center. We'll talk a little bit about tuning in different language models and perhaps making the system more appropriate towards what you're looking for. Accuracy is correlated to confidence, but it's not quite the same thing. We measured confidence pretty easily with how many words are available to pick from a particular word. So confidence is based on how many word options for every utterance and how it fits into that context. So making sure that you're looking at a sentence with a verb and a noun and everything sort of all ties together with punctuation and how that particular word fits into that context. Accuracy is based on a number of things and can be affected by the sound quality, the audio model, so how it's heard. Things like that can be impacted by how far away the microphone is from the person talking and how much background noise there is. But then also the language model, what utterances are mapped to which words. And we'll talk about tuning in just a moment. So with the Enron data, the documents that were found on shared drives were used to determine the accounting fraud. The emails were really used to determine intent, and the voicemails that were used in the voice analysis were used to determine inappropriate attitudes, unlawful activities, and unwritten agreements. So it's worth noting at this point, and you'll see this also in the demo, that the Nuix Voice tool is measuring mood, so it can tell if it's a happy phone call or an angry phone call, if it's getting better or if it's getting worse. That can be a very important part of doing a litigation discovery or a compliance analysis. If all the calls coming out of your call center seem to be angry phone calls, you might want to investigate for a particular reason. And that, once again, has nothing to do with the words per se, so not necessarily compliance or litigation words, but just the tone of voice. So the discovered files in the Enron case audio were indications of a lack of concern for those being stolen from. Basically what was happening was they would be shutting down sources of electricity, which would cause the prices to spike, and then they would call people and say, this is your current rate, let's sign a contract at that rate. They referred to those people as Grandma Millie, and they also called the program Ricochet. What's interesting about those terms is they're not the kind of terms that you would normally see during a compliance audit as being something wrong. They were sort of hidden terms or secret terms, code words that they were using to identify this activity. Once the investigators knew that those words were there, you could then search the data and find Grandma Millie and find Ricochet, but they weren't the kinds of things that you would find up front. So they weren't standard compliance terms, and they wouldn't have appeared on a standard query set for compliance. So we'll talk a little bit about the difference between the two of those and what that means for how you might want to set up your system. So a little quick comparison between accuracy, uniqueness, and confidence in the data. Accuracy, what you'll find is that unusual words are found accurately, but they're not necessarily indicative of anything unusual. So for example, you'll find iPhone. That might be a perfectly accurate word, but it doesn't help you discover whether or not there's risk or fraud going on. There is uniqueness, so words found in the audio but not found in the emails. Now this is one of the big lessons learned for me is there's a lot of things that we get away with saying when we talk on phones that you wouldn't get away with putting them into emails or in documents. There's some obvious terms on the right that you'll see there that are unusual words, things that you wouldn't, but anyway, we did a word list comparison, took all the words that appeared in the audio and all the words that appeared in the emails, and the words on the right were words that were found in the audio but not in emails. And the volume of those words appeared. So that's an opportunity to say, are those words that are maybe either being transcribed incorrectly or things that we need to look at? So then confidence, as I mentioned, is how many alternate words that could be misinterpreted. And we'll talk about some examples, specific examples that came up. So the word list on the right are frequent, unusual, and highly unconfident words, which we were looking at for substitutions. And that's one of the ways to increase the accuracy of your model. So words that are relevant and unique to the dataset conversation. So what would you expect a trade call to contain? And that's part of what a compliance approach would take. So from a compliance perspective, in the absence of wrongdoing, what do people say to indicate a pattern of activity? Some words can be tuned for better recognition as they're misinterpreted as common words. So the FERC was the interesting one. FERC is not a standard English word and therefore didn't appear in the standard dictionary for words. But also it had not been a word that the language model is trying to pick up specifically. So you can see there's a lot of variations when FERC appeared with, so the FERC is the Federal Electrical Regulatory Commission. It appeared in different contexts in the sentences. It was not typically misinterpreted correctly at the same time. So It might not be a good example for where you'd want to do a substitution, but would be a great example where you'd want to say this is actually a word that we want to add to the dictionary. So some words are accurate, just unusual. Many common words are useless in this context. So one of the more common words that you'd find, like I mentioned, we don't talk the same way that we write. So people are going to say like, you know, like, like we're going to, you know, like, you know. So that we found a fair amount of that. That kind of language also makes it very difficult to do things like linguistic analysis. What is somebody saying when they're saying like, you know? Because there's a lot of variation to that. You can find two people saying exactly the same sentence using like and you know, and they mean completely different things. So intent and purpose are different than the actual words being used when you're looking at audio content. So a comparison of those two approaches. An eDiscovery approach means that you look for suspect words that are in a similar time frame as emails. So looking for grandma Millie, things that appeared specific ways in specific places in a consistent manner. So having, from an eDiscovery approach, having emails, documents, and text from audio in the same case is a very useful process. You look for known suspect situational words. Obviously, if you're going to do a number of legal cases across a number of different industries, looking for grandma Millie and ricochet aren't going to be useful. But once you discover that those words are being used in that particular fashion, this is an excellent way to go through and find those things because they are unusual, therefore they're highly accurate. And you can get really good results from that process. From a compliance approach, you really don't want to look for those types of words. You want to look for word sets over time as a trend based on compliance criteria. So in this case, some of the words that you would look for finding spikes in electrical power might be things like congestion, shutdown, a price cap. Building those into your analysis and looking at those on a quarterly or daily basis is really where you want to focus your energies from a proactive compliance perspective. But you want to focus on the unique high confidence terms. So there's two ways to improve the accuracy. One of the things you'll discover if you ever try and play around with Nuix and Vokey and the Enron dataset is that the current model was not specifically tuned to the Enron dataset. There are other products in the marketplace that have specifically tuned to the Enron dataset, which means they'll have a higher accuracy on the Enron dataset and perhaps a lower accuracy in a call center or in a litigation case. So be aware of the fact that you can train how it listens to a specific dataset based on all the environmental variables that go into it. But basically creating substitutions is where you find frequently and consistently mistranscribed words that can be switched just in the dictionary. A substitution process is like a search and replace, and it's fairly straightforward, easy to add in. The best example I remember hearing from the guys that work at Vokey was the example of big whales versus big hails, and which one is more likely to hit your car in an insurance claim. When big whale appeared, it was probably not about big whales, it was about big hails. So that's a simple substitution that you can find, and that drastically improves a lot of the accuracy. So you want to do substitutions with things like industry terms, your company name or specific products that you have, cases that you run across, external entities that you interact with frequently, or any specific regional changes. And all these can be made fairly simply. You can also go through the process of tuning the audio model so that it could hear things like what does FERC sound like when it's pronounced. So retraining the acoustic and linguistic models to meet your specific needs. You get better results across all types of terms and utterances over the door. And it also allows you to open the door to accents, occasional languages, inconsistent topics, or search terms. It's also the way new languages are brought online, and it's worth mentioning Vokey right now has English US, English UK, English Australia. Apparently the Australian model is doing quite well in accuracy, which I think is interesting. Recently released language models include Spanish for Spain and for Latin America, which I can tell you Argentine is different than Mexican, but nonetheless. And a number of other European languages in limited release right now that are going through testing and will be part of the tool very soon. So finally, Snohomish Power was the other one of the participants in the litigation case. They obtained 2,800 hours of conversations involving the Enron traders. So if they had used about $28,000 worth of Nuix Voice, it would have taken them 1.16 days on an appliance, 3 days on a laptop, and 47 days on a VM, just because of the speed and performance that we did as part of this benchmark. And to do this, they spent about $100,000 transcribing these tapes using 233 staff days to do it. So that's really where the cost benefit is in this. If you have one file that you need accurately transcribed, it's probably not the most efficient way to go about doing that. But if you are a data center or call center and you've got 5,000 hours per day being created and you want to do more than just an occasional spot random audit sampling, this is an excellent way to get through that large and start seeing trends in discussions, trends in attitudes, trends in potential problems that you might want to be addressing. So these are some numbers that came from Vokey. Part of the reason that we wanted to do our benchmarks, and like I said, our benchmarks map quite well to their benchmarks. A number of different ways that you can buy Vokey depending upon things like what language models you want to be processing, how much RAM and CPU you have available to, and what expected speed are you hoping to get from it. As you can see, a small VM is getting you 1 to 2 times normal speech, which generally is not something that you really want to try and even accomplish in a production environment. But as you see, the larger you get, and here's the next slide, the more you get towards large multi-volume appliances, you can really get through multiple times, multiple thousands of hours in an hour processing speed to get to the whatever requirements that you have. You only need to buy as much as you need. We sell the hours in chunks to make it easy to buy, so you don't have to buy more than you need. If you want to consider buying some Vokey and trying it out or using it in your production environment, there's a couple things you need. The first is you need some hardware to run on. We can provide that. We actually recommend it because some of the parts and pieces take a little bit of time to order if you're doing it separately, but you can run it as an appliance, as a cloud, and as a laptop. It runs on CentOS and Red Hat. VMs are very good for testing functionality and the integration and the training, and perhaps even building integrations if you want to, but generally not something that we'd recommend for a production environment. You need an integration to Nuix so that you can look at the audio text in the same context as the emails and the Word documents, or if you don't want to do that, you don't. And Michael is going to show you in the demo in just a second what that looks like if you just go directly to the appliance itself. And then you need to figure out how much volume you have and how much you want to buy. And if you can reach out to us to find out what those expectations might be and how to go about moving forward with this. And that's what I have to say from our slides, and now we're going to go jump into a demo from Michael Lappin. And I think...
Yeah, that was great, Brock. Lots of good info there. Okay, guys, so we have a few minutes left to show both the Nuix Voice interface and how that appliance works, and do some samples and listen to some audio from Enron. And then we can also take a look at the bigger picture in the Nuix workstation, how we bring all that together, because really a big part of this message is around federating the experience for our eDiscovery specialists and our investigators. And I'll take you through that. So this is the dashboard for Nuix Voice. This is very easy to install, guys. It's basically an OVA file, and you can blow that out to a physical or a virtual appliance. You can host it in the cloud, however you'd like. And as Brian just said, you can load data directly in here if you want. And then I can also show you how you do it from your workstation when you encounter those WAV files, MP3s, MP4s, about 162 other formats that we support currently. So lots of all of the common video and audio formats. And we also often will do things like, let's convert another form that isn't within the 165 supported formats. Let's turn it into something that is supported. So that's another way to support those real weird ones that you might find out there that do exist, and every day, of course, there's new files. That's what Nuix is known for discovering. So the dashboard here looks like this. We've got some graphical overview, some sort of call statistics that you would see. You know, if you're in a call center, in a data center, or you're analyzing that kind of stuff. I don't have any brand new calls, but what I am going to do is show you down here below is where our Enron data is listed. We're going to get into that in a second. We also have a variety of folders. I'm going to show those to you and explore how those are different. What a folder does is allows you to categorize how you want to treat the data, specifically what language model you want to use, which is obviously very, very important to getting it right. If you use Australian English and it's actually American accent in English, it doesn't come out as good. So you want to be specific about that. So what I've done here is I've sorted by date. You can see that I've sorted back into September. I'll just bring it forward to December to demonstrate this here. And I've got a group of files. These files are the Enron data set, the audio files that Brian went ahead and ingested directly into the appliance here. We can search now across what the speakers say, whether they're the agent or client, and that's just the two different callers that might be conversing on a particular call center interaction. We can also just search the file name or the agent ID, and I'll do that in a second. We can search by gender, and we can determine that, and our speech-to-text capability does determine if a person is a male or a female within the agent or the client. Their overall emotion, which you'll see color-coded in a couple of examples that I'll show you. So is it positive? Is it upbeat? Is it optimistic? Much like this webinar will be all green. You'll see in the calls that webinars like this were very positive, and our languages overall, the emotion is positive, wherein things like a 911 call or one of these very confrontational broker-dealer trader calls that Enron has will show a negative sentiment, a lot of negative words and things like that. Part of the modeling that we can do. Call duration, you can see I can specify whether I want long or short calls, calls with a lot of silence, and calls with a lot of a good or poor clarity. Why these are important is because this might be your mechanism to examine those calls that may have some static, or they may be dropping in and out due to cell phone coverage. Some of that real-life stuff that could cause maybe some inconsistent or not really well transcribed files. So not to worry, you can get to the bottom of those things pretty easily by looking at just the items you want to see that have a clarity issue or a lot of silence where no one is speaking. That can be kind of interesting in ferreting out the context of the call. Why are they being silent? Is there some reason? Is it technical or is it something emotional? All right, so let's do a little bit of a search here. I'll add a keyword of California and see my entry goes down to about 34 entries. And then I'll also add the word energy. These are common words in the old Enron data set. And you see I've got some sort of snippets of what I might be able to look at now. So if I was to, say, click on one of these, it'll come up here. And you'll see another browser window opening. And you'll see the conversation as it's been transcribed. On the left, we have a variety of interesting metadata. Here is that clarity ratio, the silence quantity, the duration, the gender, the emotion, and that type of information is pretty important. We're also going to add to this momentarily in our workstation the accuracy ratio. So here where you can download a copy, if you like, in both text, JSON, or MP3. So it has been transcribed, so let's grab it in text. Or if I'd like a copy of a relatively easy to play and listen to MP3 format. I can also start and stop where I like within the conversation, scroll down through it. You can see the emotion being detailed here by an overall red or pink, as well as green for the opposite being positive. I've got a variety of other calls here. You see I've got them displayed, so I can see and look at and read as many as I like. And then I can just play these too. So let me see if I can't play one for you here. I'll actually put it up to my phone so you can hear it through a special speaker that I have.
Hey, Paul, Steve. Hey, man. What's going on? I just wanted to update you on prices. Where we at? Hey, I got to ask you something else. Yeah. We're hearing this nasty rumor that I guess there's a potential that California could be asking for money back, refunds. Yeah. You think that's a possibility, or is that it's a possibility. We put a low probability on it, but we're asking a biased question. That's why I talked to, and I forgot to talk to you and Tony about it. But
okay, so that's just a little snippet of one of the calls that does have some interesting text there around nasty rumors. So maybe that would be the kind of file that we would listen to, or we would transcribe, or we would investigate in some manner. So pretty easy to do that, you can see. Okay, so let's go back to our dashboard here for a second. I want to talk just about a little bit about the foldering a little bit more. So if I go into my settings and my folders and apps, you'll see here I've got a whole lot of folders. And you can see the important, look under the model or channel number, and then the number of speakers and the audio source. Brian was talking quite a bit about mono versus stereo. You see here we've got English 1. You scroll down, you start to see English 2, English 3. So these are the different models, whether they're Australian, whether they are English or British English accents. And this can be pretty important. This will be, as Brian also alluded to, important in the transcription of different Spanish dialects, as well as Brazilian Portuguese, as opposed to maybe Portugal Portuguese. I know we've got some of our Brazilian friends, Nuix partners on the phone today, and they're testing or eagerly awaiting the testing of the Portuguese language model. So it's very simple here. If we just go down, I'll just show you. If we go into our Enron benchmark, this model here, it's as simple as going out and browsing the file system to upload the hundreds of different Enron WAV files. Now, of course, these could be MP3s, MP4s, a variety of different things, but it's very easy to then add them to your, your corpus. And as Brian also said, when we start to add duplicates, they won't be reprocessed. They'll just be checked for their hash, so that we'll see, okay, I've already done that work, and here's a copy for you if you need it. Because we do, of course, in eDiscovery investigation, see the same files over and over again, right? So that's a pretty important detail as well. Okay, so this is just the voice appliance. This is doing the speech-to-text analysis and transcription. Let's expand the discussion just a little bit to increase and include the Nuix workstation. You probably all know on the phone, this is the practitioner's tool. This is the most popular tool in the variety of Nuix products that we all use and our partners use and has been around for many years. This is where we can start to process data. We can search, tag, we can cluster, we can export data from here. And this is complemented, of course, by our Nuix Web Review, Nuix Director, our Enterprise Content Collection Center, etc. But right here is where I've got a corpus of data that includes not only the Enron data that is audio, but other Enron data that isn't. So the message here, guys, is that federation is really the key to this experience. You see, I've got a variety of evidence here in my document navigator, and I've got, you can see in the review, in the results pane, a variety of different types of files. There's PowerPoints, PDFs, there's emails, there's Word documents, and I can, of course, come down here and sort on these. So if I wanted to grab my emails, I could populate them this way, and here you see some Hebrew. So obviously lots of different languages supported by Nuix, and some of the Enron data is in here, a lot of blank items, top secret stuff. So all kinds of email, and you see I've got calendars, I've got presentations, I've got spreadsheets, I've got documents. Let's clear this out, and then let's focus again on the audio. If we come down to my tag section, here is a group of items that have had the Vokey transcription actually completed. If I was to just show you some of the Enron ones, let me show you what it looks like before they're transcribed. You basically have the group of files here, and you have only this metadata. So you have only this metadata that I've shown on the preview pane. So you've got file size, file type. You've got a Nuix GUID that's been supplied during processing. We have an MD5 digest, obviously very important. We have the MAC dates for this particular file. We probably know what kind of file it is. It's a WAV file. Now, after transcription, what is open to you now is all of the properties that we normally will index, and you see that doubled the number of things that we could search upon in the properties section. And when we look in here in our text, we now have the WAV files with the same level of sort of deposition type presentation in the preview pane, where you see the different agents and clients talking. We see the time spent on the call talking, what position within the call chronology they were speaking to each other. And now this is all searchable. So all of this text now can be searched in the same manner that it was within the set up on the appliance. So here's a few that do respond to California and energy. You see the hit highlighting, as you would expect in doing your investigations in eDiscovery. So now you can proceed to do things like tag this data, perhaps import it to some format that your outside counsel or opposing counsel requires, perhaps, something like that. So what we've got now is bringing in the audio and video data into the discussion of Nuix. We all know that Nuix supports over 2,000 different file types for processing and indexing. Now we add in the 165 audio and video file formats to do the same thing. Brian also said that earlier on you will see these types of files segregated in the multimedia section of your navigator as well as your statistical analysis when processing completes. So much like we will deal with OCR candidates, like unindexable PDF files, we can then churn those through the old OCR engine in Nuix. Same idea. We're going to OCR this audio by pushing it up to the Nuix Voice appliance. And the way we do that is we would just select the items we like. I'll just select the whole corpus. And then I'll go up here and I'll grab my Nuix Voice connector, and I'll just take you through this and I'll be done. And this describes where the folder is, where that Vokey or voice server is, the ports we're going to send it to, and the ports that are going to send it back, and what kind of language model we're going to use. We also have some annotations here. Would we like to convey the sentiment, the overall emotion, the duration, etc.? That stuff will then come into your Nuix workstation case, so you can continue the workflow on that data. So you push it up, it comes back, and voila, you're ready to go and continue to work much like you had anticipated, and not miss anything in the transcribed audio files, which is really, really important. What's sometimes scary is presenting or producing data in its audio format without actually knowing what it is. And obviously, sometimes it could take hundreds and thousands of hours to actually sit there and listen to that, right? So that's a really important part of the value proposition. One of the things that Brian and I talk about a lot is, transcription confidence. These are fairly high. These have, you can see here on the bottom, transcription confidence of 0.72. I'll just kind of click around and we can see, here's another one that's very high at 0.95. What's amazing about the value of this, guys, is the ability to transcribe hundreds of thousands of hours very quickly, thus being able to be more compliant than trying to have human beings sit with headphones on in little booths to try to listen to 0.1% of hundreds of thousands of hours. This gives you the ability to get very, very accurate capabilities across hundreds of thousands of hours with a ratio of only about 100 hours of audio to 1 hour of machine time. So that's where the ROI comes in, to actually looking at very, very large quantities. I was recently involved in a POC. One of my engineers was doing one for a very well-known federal entity who was transcribing at one time 100,000 audio files at one time on their Nuix Voice appliance. And they would just let it run, right? And they'd come back in a day or two, and they'd have it all ready to examine. So you can see why this mass capability, and processing it in mass and transcribing it really does make a lot of sense. Okay, with that, I think I'm done with my demonstration, so I'm going to stop sharing. I think now, Brian, we're going to take a look at some questions that may have come in. I've got about 4 here now that I'm going to throw at you, Brian. You ready?
Yeah, I'm ready. I'm here.
Okay, here's one. Can you use near deduplication and clustering on your audio files in Nuix Workstation?
That's an interesting process, because a lot of what we were trying to do in the case study was to map together the discussions and emails with the discussions and the voicemails. For the most part, the answer technically is yes. I think what you'll find is that it tends not to be very accurate, just because of the fact that when people speak, they often throw in non-words such as ums and ahs and you-knows and gonnas, which decreases the level of similarity in the similarity cluster. Perhaps a better way to do that kind of thing would be in a word list, so looking at the words that show up in a case, or perhaps topic modeling. But for the most part, near deduplication is technically any of the analysis and classification processes that you run through, you can run through using voice analytics the same way. Just your expectations on what you get as results would be a little bit different.
Yeah, that's a good one. That's a good one for sure. I know we use a lot of clustering when we look at finding the near dedupes and things that might be predominantly redundant, outdated, and trivial. So it's a powerful capability. Okay, we got another one here. With regards to the machine learning component to this solution, is it helpful to have a large dictionary?
Yeah, so this was, we did mention this in one of the slides briefly, but basically the general concept is if your dictionary is exceptionally large, it takes more resources on the system. It takes longer to get through the analysis. It's more likely that you'll hit an obscure word that might be an obscure word in your dictionary, but it also tends to mean that there might be multiple words that are pretty similar to the word that you're looking for. So whether or not that improves your accuracy or doesn't, it really depends on your language and your data sets and where you're going through. In general, it's better to start with a smaller data set and then only tune it to the additional words that you know you're going to be dealing with. But it's a flexible thing, and the ability to learn, the ability to tune, and the ability to add substitutions are an extremely important part of this, just because every collection of audio data that I've ever tested or run against has been recorded in a different environment. And we know that the number of ways that we can record audio these days is growing. We now have policemen with body cams on them. And of course, the accuracy of a body cam situation might be quite different because everybody's probably yelling and there's a lot of background noise. And so, you know, figuring out how you're going to address that is going to be a very different type situation. So yes, the larger the dictionary doesn't necessarily mean the better the accuracy. You just need to be judicious with what you do and what you add and how you configure that.
Yeah, good one. I got a bunch coming in here, Brian. We're going to go rapid fire here.
Okay.
French translation possible. I know it's planned. Any comments on that one, Brian?
Yeah, I believe that's limited release at the moment, so the core functionalities there, the ability to integrate it into the tools there. We're at a position with Vokey where we need to find some early adopters to help us validate and tune and process. That's true with most of the European languages. Some are farther along than others. But like I said, they're at the moment now where they're fairly small dictionaries, so it may be perfect for the type of environment that you're looking at, and it's probably a good time to consider that type of audio for a specific focused use case.
Yeah, good one. Yeah, that comes from one of the audience members named Paul, and he has a French last name, so he may be legitimately interested in doing that. So Paul, you should catch up with us later. He also wants to know about pricing. I know we base the pricing, Brian, on 1,000-hour or larger blocks. Can you comment on pricing?
Yeah, so pricing is really, it's an interesting thing because what we find is that if you're in the litigation side of things, your volumes are very unpredictable. You don't know how much audio is going to be in your next litigation case. If you're in the compliance side, you've got a much more predictable set, and so you can define how many hours per month that you want to process. Obviously, with just about anything that you might buy in bulk, the larger the volume that you're buying, the greater the discount you can get on the pricing. But generally, we sell it in 1,000-hour chunks, and so we can make all kinds of deals and arrangements with you that are appropriate for the language model and the volume of content that you have.
Yeah, good one. Here's one that you were speaking about a little bit around substitution in dictionaries. This comes from Jeff. Can the language pack be adjusted to include specific terms specific to his industry? Yeah,
and I would highly recommend that in a lot of cases. One of the best examples that I think comes out is if you're, for example, a pharmaceutical company where you've got a lot of drugs that are quite long and complex and obviously not English words other than as names of products. That kind of situation, if they appear a lot, that's likely to be the kind of thing that you'd be doing your auditing on and your records management on and your compliance on. And there would be huge value in trying to focus your language models on those specific types of words. So yes, company-specific, industry-specific, product-specific, or external entity-specific type terms are all very valuable things to spend the time and energy on.
Yeah, I remember one pharma that had the, you guys have probably all heard the medication Humira, and the Vokey dictionary was trying to say that was the word humorous, like the arm bone, or humorous like funny ha-ha. And so we just simply added the word Humira, H-U-M-I-R-A, I believe, to the dictionary, and lo and behold, it transcribed their very popular product, you know, correctly from then on, right? Yeah, farmers are a great one because they always have those funny words they make up, right? Here's another one. My organization operates a large call center. If our call operators ask consistent scripted questions, how can this tool help us to zero in on answers to specific questions?
That's a wonderful question because that's another one of those things where you do have control over your environment. If you can direct questions the right way so that you get very specific types of answers. And those answers are words that you know are transcribed well. The same thing is true, for example, with language translation. If you train people how to write using simple words and straightforward words without a lot of slang, without a lot of weirdness, then the quality of the translation also improves. So it's that kind of, you do have some control. Writing scripts about what people say means you can not only control what is being said in return, but you can also then do compliance against how well is each individual doing at following the prescribed the prescribed script on the call. So it's a good performance auditing as well as compliance auditing type capability.
And of course, you can search on the words and phrases in both the workstation and the appliance pretty simply, assuming, like you say, they're transcribed well. A couple of functionality questions. I'll try to answer them quickly because we're coming up to the top of the hour. Is there a way to use Nuix Workbench to redact the audio content out of a file? We don't redact the audio content, but we can redact the transcriptions, right, Bri?
Yes. Yes, the web tool also has an application called Purify, which allows you to redact out from the audio files when it's coming from the server. But that's not something you do from within the Workbench.
Right. So not in the Workbench. So in the appliance, guys, Purify allows you to specify specific words, phrases, and PII that can be redacted out of the transcription. Another one. Let's see. Can Nuix import into relativity? Yes, Nuix Workstation has for years and years been able to export into relativity load files as well as directly into the relativity API. Let's see, I think we're coming up. I think that's the last one we can take, unfortunately, guys. Great questions, quite a few. So thanks, everybody, for joining us. Brian, you want to see us out here?
Yeah, thank you, Michael. Thanks for the demo. It was nice. We're obviously happy with this wonderful partnership, opening up a lot of doors for us from a technical perspective. We're more than happy to talk with you about accuracy, direction, language packs, any of the stuff that might be relevant to what you're looking at. And like I said, just feel free to reach out with any questions that you may have. Thank you for attending and have a wonderful day.
Thanks, guys.